Hello and welcome to Pharmacy Business Math. Today we are going to go over the different types of business math problems that you may see in the pharmacy field. We're going to calculate the cost for a desired amount of medication. We're going to calculate a markup, markdown, and markup percentage. We're going to calculate profit, add a dispensing fee, and then we're going to put it all together at the end for a combination, dosage calculation, and markup problem. Tips to solving some business math problems is that if you see the acronym AWP, that stands for average wholesale price, this is the same as cost, or they may use the term invoice. Okay, so they may use invoice as another term. They all mean the same exact thing. To change a number into a percent, we're going to multiply by 100. To change a number back into a number, we're going to divide by 100. We're also going to look at a dispensing fee. When we see a dispensing fee, it's always added as our very last step. So let's take a look at our first type of problem that we're going to see. So we're going to calculate the retail price of a prescription for 30 tablets if a bottle of 1,000 tablets has an AWP of 88.05 and the markup is 40% and there is a dispensing fee of $9. So the first step that we're going to do is we're going to calculate the cost of a desired quantity of 30 tablets. So if I know that 1,000, I have 88.05 for 1,000 tablets. So if I divide that, that gives me the cost per tablet, and then I'm going to multiply that by 30 to get my cost for my 30 tablets. So I have 88.05 divided by 1,000. Times 30, and that gives me $2.64. So this is my AWP for 30 tablets. The next step is we're going to go ahead and calculate the amount of a markup, and we're going to do this by taking our AWP, which is 264, and we're going to multiply that by our markup, which is 40%, but we're going to multiply it as a number. So remember, to change a percent into a number, we divide by 100. So I have 264 times 40 divided by 100, and I get $1.06. So this is the cost of my markup. The next step is we're going to add the markup to the average wholesale price to get our selling price. So we have our original price, which is $2.64 plus $1.06, and that's going to give me $3.70. So this would be considered a selling price. However, we have to add in our dispensing fee, because there is one given of $9, so $3.70 plus 9 is $12.70. So this would be my retail price. So that's how you would perform a problem where they want to calculate the retail price based on a markup and a dispensing fee. Now you also may see problems that will have you calculate a dispensing fee, and they'll give you this table. This is a dispensing fee table. So the retail price of a prescription based on average wholesale price plus the dispensing fee. So we want to use the following fee table to calculate the retail price of a prescription for 30 tablets if a bottle of 100 costs $74.25. So the first thing that we want to do here is we want to calculate the AWP for 30 tablets. So I know that it's $74.25 for 100 tablets, but I only want to know the cost for 30. So I have $74.25. I'm going to divide that by 100, and I'm going to multiply by 30. And then I get $22.28. So this is my AWP. Now since the price or the dispensing fee is based on the AWP, I'm going to take a look. Now my AWP falls in the $20 and up range. So this will give me an AWP of $7.75. So I have 22.28 plus $7.75. And that's going to be my retail price. And I get $30.02. Or actually I get $30.03 as my retail selling price. The next type of problem is when we calculate profit. Profit is the same concept as markup. So let's go ahead and take a look what this is going to look like. So if Pharamcy wants to make a 25% profit on an item that costs $5.45, what would the retail selling price be for a pharmacy to make this profit? Second question would be, and what would the amount of the markup be? So I need to apply this profit. So my AWP is $5.45. So in order to apply my profit, I'm going to multiply it by the percentage as a number. So when I want to change the percentage into a number, I divide by 100. So I have 545 times 25, divide that by 100, and I get $1.36. This is actually considered the amount of markup. Now to get the cost, I'm going to take my AWP and I'm going to add the amount of my markup, and that's going to equal my selling price. So I get $6.81 would be my selling price for this particular product. Next, we're going to calculate a markdown. A markdown is the same as a discount. Now, the process is almost the same. However, we're going to subtract instead of adding. So this is what this is going to look like. So first things first, we have a retail pharmacy is having a sale on over-the-counter products if the product's regular price is $12.45 and it is to be marked down 25%. What will the selling price be of the item? So here I want to find out what 25% of $12.45. So I'm going to go ahead and multiply it by the percentage as a number. So I have $12.45 times 25 divided by 100, and I get $3.11. Next, I'm going to go ahead and take my original price and subtract my markdown. So I have $12.45 minus $3.11. And I get my selling price now is $9.34. Next, we're going to have a markup percentage. Now, markup percentage is based on the equation. We have our retail price minus our average wholesale price divided by average wholesale price. And then we multiply that by 100, and that's going to equal our markup percentage. So what we're going to do is we're going to go ahead and follow the equation. It says, what is the markup percentage on a box of latex gloves that is invoiced at $4.36 and sold for $5.99? So the selling price is $5.99. We're going to subtract our invoice, which is $4.36. We're going to divide that by our invoice, which is $4.36, and then multiply by 100. So when I put this into my calculator, I'm going to take $5.99 minus $4.36. Now that is in parentheses. So what we're going to do is we're going to equal that out. So minus $4.36 equals. Then we're going to divide by $4.36 and then multiply by 100. So I get 37.39%. All right, last but not least, here's our combination problem. Now it's very important to be familiar with dosage calculations here. So it says a prescription is written for 400 milligrams of an antibiotic to be given by mouth every 6 hours for 10 days. The antibiotic comes in an oral suspension in a concentration of 200 milligrams per 5 ml and is available in a 100 ml bottle. One bottle of antibiotic costs $500. The technician did the calculation to determine the number of bottles to reconstitute. They determined they needed 6 bottles and continued with reconstituting the 6 bottles and preparing the labels. On final check, the pharmacist was very upset because the technician has cost the pharmacy money because of poor calculating. How many bottles should have been reconstituted and how much money was lost by the pharmacy? So this problem could be a little bit scary, A, because it's long, and B, there's a lot of information. So let's go ahead and start pulling out some of this information. So here, they're saying that the technician made 6 bottles, but it was wrong. Okay, the pharmacist was upset. So if I know that they're dispensing 6 bottles and it's wrong, I actually need to figure out what the quantity dispensed should be. So in order to do that, I'm going to take a look at what's given to me for my prescription. Now it's written for 400 milligrams as a dose to be taken every 6 hours as needed for 10 days. Now this is the available 200 milligrams per 5. So I need to know how much of that 200 milligram per 5 ml suspension is needed to satisfy the entire prescription. So if I know my dose is 400 milligrams, and for every 5 ml, they're getting 200 milligrams. My milligrams will cancel, so I have 400 times 5 divided by 200. That gives me 10 milliliters for one dose. Okay, but I'm not done yet because I need a total quantity dispensed for 10 days. So if I'm getting 10 mLs per dose, they're getting it every 6 hours, so that's 4 times a day for 10 days. I need a total of 400 mLs. Now if I need a total of 400 mLs and one bottle, I need to know how many bottles. One bottle is to 100 mL, so I divide 400 divided by 100. I only needed 4 bottles to begin with. So this would answer my original question of how many bottles should have been reconstituted. Now, how much money was lost by this pharmacy? Now, the original mixture was 6 bottles. All right. However, I only needed to give them 4. So I had 2 bottles left over which I couldn't use, and each of these one bottle is $500. So 2 times 500. So this cost the pharmacy $1,000 for this error for poor calculating. Okay, that concludes our video on business math. If you have any future questions, feel free to contact one of our coaches at coaches.ultimatemedical.edu. Thank you.